Hi everyone. So it seemed that topic 10 was the topic where most people struggled with. So we're going to go over our trigonometric equations. So if we're looking at a XY coordinate grid, we have our four quadrants. We have the first quadrant, we have the second quadrant, we have the third quadrant, and we have the fourth quadrant. Now, in the first quadrant, all of the trig functions are positive. In the second quadrant, the sine function is positive. In the third quadrant, the tangent function is positive. And in the fourth quadrant, the cosine function is positive. Now, that's all good, and it's good to remember that all students take calculus, and that's where the memory mnemonic device comes from. But it's also important to know why that happens. And for any of us that are taking physics with me this year, this is going to be a twofold lesson for you because it's important to understand why the sign is positive in the second quadrant. So I'm not going to go over all of them, but I will just go over the second quadrant, and hopefully you could see a pattern there. How this comes about is if we talk about some angle in the second quadrant, now the reference angle creates some angle theta, right? Some angle theta from our x-axis, and it's always from our x-axis. And with this reference angle, it's created from the x and y components of that. So in order to get this angle, we have to go over some x amount. We have to go over to the right some x amount. But we also have to go up in the y direction some y amount. Now, what those amounts are doesn't really matter for what I'm explaining here, but what does matter is whether it's positive or negative. So if I go left in the x direction, that would be a negative direction. If I go up in the y direction, that would be a positive direction. And our green arrow, which is the result of the black and red arrow, that will always be positive because in order to get this hypotenuse, we're using Pythagorean theorem, we're getting a sum of components, and more importantly, it is in two directions, right? It's not just in a west direction or a north direction, it's in a northwest direction. So technically, you could say it's positive or negative, but it will always be positive, that hypotenuse. So where does this come into play with understanding why sine is positive in the second quadrant? So to make that connection, we now need to look at the fact that the sine function, the sine of some theta, is equal to our opposite side over our hypotenuse side. So when I'm looking here, my opposite side for this right triangle is that positive red arrow in the y direction. And the hypotenuse is our positive arrow that's green there. And both of those are positive. So no matter what the values are for the red arrow or the green arrow, they're both positive. So therefore, the sine function will be positive always in this quadrant. If we were to look at cosine or tangent, we'll see that it will become negative because if here's the for the cosine function, it would be the adjacent is the negative side, the x direction side, over the hypotenuse, and a negative over a positive is a negative. And finally, for the tangent function, it's a positive over a negative, and a positive over a negative will still stay negative. So that's why the sine function is the only function that is positive in the second quadrant. And you could go over that same process with tangent and cosine in the third and fourth quadrant, and you'll see that that still applies. And that's a really, really important concept for physics, but also for calculus as well. So getting on to actually solving these problems. So number one says the sine of x is equal to 1/2. And we have to note that it's on the interval, the closed interval from 0 to open interval of 2 pi. So what that means is 0 is a possible answer for any of these problems. However, 2 pi is not a possible answer because of that open parenthesis. So when we see the bracket, that's including the answer. Open parenthesis does not include the answer. So for the sine of 1/2, well, first of all, it's a positive 1/2. And because it's a positive 1/2, the sign is positive in the first and second quadrant. So we want to know what are my x values in the first and second quadrant where we have 1/2. And what I like to do is just draw a quick sketch. And I want to label my side. So the opposite side is 1 and the hypotenuse side is 2. And what triangle would satisfy that? That would be a 30, 60, 90 triangle. And And more importantly, it would be when we have a 30-degree angle that is across from the side labeled with a 1. So therefore, our x values would have to be at pi over 6, and the other spot where it would have to be in the second quadrant is 5 pi over 6. If you struggle with coming up with what are the two values, I look at it as if this is 30 degrees, I think what would, if I multiply it, what gives me, in this case, it would give me 180, right? So 6 times 30 is 180, and that's good for us because basically this is all boiled down by the fact that for every pi degree there are 180 degrees, and we're taking a sixth of that. And if we took a sixth of 180, right? If we took a sixth of 180, we get 30 degrees, and that's where that value is coming from. Now, for this next angle, how do I know it's 5 pi over 6? Now, once I've determined it's over 6, I just need to ask myself, what is the next numerator value that I could put over 6 and it will not reduce, number 1, and number 2, it will be less than 1. And again, it has to be less than 1 because from 0 to 180 gives me pi. So if it's less than 1, it's got to be pi or less. So I have 1 pi over 6, 2 pi over 6 would give me pi over 3, 3 pi over 6 would give me pi over 2, 4 pi over 6 would give me 2 pi over 3, then 5 pi over 6 is the next one that does not reduce. So therefore, those are my two answers. For number 2, we have a squared trig function. And typically with a squared trig function, we're going to have to either factor or take the square root of both sides of an equation. In this case, I would simply subtract the cosine of x from both sides. And when we do that, we want to factor out a cosine of x. And now what we want to do is, once we factor that out, we could set each of these equal to 0. So when the cosine of x is equal to 0, and when the cosine of x is equal to 1, because we would add 1 to both sides. So the cosine of x is equal to 0 whenever it's along the y-axis. So that would be like here and here. So that would be pi over 2 and 3 pi over 2. And the cosine of x would be equal to 1 whenever the x value is positive, because remember, cosine is dealing with an x value. So when is the cosine of x equal to 1? Well, that would be over here at like 1 comma 0. So that would be 0 and 2 pi. However, 2 pi is not in the interval, so therefore 0 is the only possible answer we would get from positive 1. Okay? I'm not going to do number 3 entirely, but just make sure that you subtract the root 3 to both sides of the equation. And then divide both sides by 2. So it's when is the cosine of x equal to a negative? So you should be saying to yourself, well, if it's negative, well, it's got to be in the second and third quadrant because it's positive in the first and fourth quadrant. So what two cosine values give you a negative value? And that's why your two answers should be in the second and third quadrant. So you can do that on your own. I'm going to do number 5 next, and then I'm going to do number 9. And then hopefully you could try the other ones if you haven't done them already on your own. So with number 5, we want to subtract 1 from both sides. And the reason that we're doing this is we want to set this function equal to 0, because to me, this looks like just a classic factoring problem, but instead of x's, it's sines of x's. Because if we had 2x squared plus x is equal to 1, I'd subtract the 1 over and factor it. So we still want to do the same thing there. So now I'm going to factor this, and you want to just kind of think in your head, well, if it was x squared plus x minus 1, what would I have? I'm sorry, 2x squared plus x minus 1. I would definitely have a plus and minus 1 to end it. Since it's -1, there has to be a sign change, and those are the only two values that will multiply to that -1. So for the first term, though, it's 2 sine of x. So I definitely have a sine of x for each term, but I need to determine where does the 2 go. And where the 2 goes will make a big difference because of the fact that I want to make sure that the sine of x is positive. And make sure the sine of x is positive, we check with the inner and outer terms. So the inner terms right now give me a positive sine of x. The outer terms gives me a negative sine of x. And if I added those, that would give me 0, which is not good. So I needed 2 to either go in front of the first term or in front of the second term. We're going to put in front of the second term because we want this sine of x to be positive. Because positive 1 times 2 sine of x will give me positive 2 sine of x. And when I add that to a negative sine of x, that will give me a positive sine of x, which is what we want for our result. So we get the sine of x is equal to -1. Oh, sorry about that. Let me write that again. Sine of x is equal to -1. And we also get the sine of x is equal to 1/2. And you guys could use your unit circle to figure out those two values. You have the answer key, so you should be able to see it from that. And lastly, I'm going to look at number 9, which is the sine squared of x minus the cosine squared of x. So if I have the sine squared of x minus the cosine squared of x, what I could do is I could add the cosine squared of x to both sides. And the reason I'm doing this is there's something clever that we could do here, where if we divide both sides by the cosine squared of x, we get the tangent function. We get tangent squared of x. Is equal to 1, because remember, if you have a term over the same term, that reduces to 1. And then from this, we're able to appropriately solve for when the tangent function is equal to 1. So you guys can finish that out by using our unit circle, but it should be, what, pi over 4 and 5 pi over 4. If you have any further questions on number 10, let me know. Also, if you want to just show me your work, or updated work and ask if it's correct, I could definitely show you or guide you on how you do that, okay? So I hope you found this helpful.